Hello everybody. Today we're going to look at what are the basic parent functions. Well, what is a parent function to begin with? A parent function is the simplest form of a family of functions. Okay, so for example, if you had something like y equals, negative 3x squared plus 2x minus 5, right? The parent of this function would just be y equals x squared, because that's the simplest form of this type of a function. So like here we have a little family. So these are the parents. They're the most simple forms, right? Just these stick figures. And just like you and your parents, you don't look exactly like them. You're what we call a transformation. All right, but today we're only going to focus in on these simple forms. All right, and to do that, we're going to look at the equations of the parent functions. I'll give them names. We'll fill out tables that'll help us graph, and then we'll see the domain and range of each. So let's start here with f of x equals x. This is a linear function. You're probably very familiar with linear functions. They're just lines, you see, and it's right there in the name. So let's fill out a table for a linear function. Notice f of x equals x. So in our table with x and y's, the y's are going to act like our f of x. And because f of x equals x, every single number in this table should just match. Negative 2, negative 2, negative 1, and so on. So when we go to graph, we just plot these points. Negative 2, negative 2, negative 1, 0, 0, 1, 1, 2, 2. So it's a straight line right through the diagonals, and it cuts through the origin. This graph will never stop going left or right, so its domain is all real numbers, or in interval notation that would be from negative infinity to infinity. And its range is also all real numbers going from negative infinity to infinity. All right, the next parent function that we're going to look at is f of x equals the absolute value of x. So this is an absolute value parent function. Okay, an absolute value is just a distance from 0. So really, whatever you plug in to these absolute value right here, it's going to come out positive. So if we plug in a negative 2, what's the absolute value of negative 2? It's positive 2. The absolute value of negative 1 is positive 1. And then these positive numbers just stay the same. So whenever we look at a graph of this, notice that these last 3 points, 0, 0, 1, 1, and 2, 2, these are all the same as our linear function. But instead of dipping into the negative over here, it bounces right back up into the positive y's. And it creates this V shape. And the best way to remember that is, remember, it's an absolute value, right? So this V in value is our little clue as to what this function is going to look like. The domain is going to be the same as for a linear function. The domain is all real numbers because the graph always goes all the way left and all the way right. It never stops. So we still have from negative infinity to infinity. Now the range here, our lowest range value is 0. So our range are all the y's greater than or equal to 0. So in interval notation, that would be from 0 included to infinity. All right, the next parent function that we're going to look at is f of x equals x squared. Okay, so every value of x just gets squared. This is called a quadratic. All right, so to fill out the table, I just take my x values and square them. And what we want to remember here is that whenever you square a negative number, it becomes positive. So negative 2 squared is positive 4. Negative 1 squared is 1. 0 squared is 0. 1, 4. And so both sides of a quadratic, they mirror each other. And if you were to go on, like if this table had a 3, 3 squared would be 9, 4, 16, and so on. Same in the negatives. So let's graph this. At negative 2, I'm up here at 4. At negative 1, we have 1, 0, 0, 1, 1, 2, 4. So this graph, instead of a V shape, forms like a U shape because it curves up. Now, even though the shape is different from an absolute value, notice that the domains are the same. The domain is still all real numbers, so from negative infinity to infinity. And the range, just like absolute value, is all the y's greater than or equal to 0. So from 0 to infinity. All right, so we have 3 more parent functions that we're going to focus on. Right here, I'm sure you could guess the name of this parent function. This is a square root. Okay, so f of x is equal to the square root of x. So let's go try to fill out this table. Remember that we're treating this as f of x. So this is equal to the square root of x. What's the square root of negative 4? It's not a real number. We can't find the square root of negative 4. So these negatives we can eliminate. Okay, so now what's the square root of 0? It's 0. Square root of 1 is 1. Square root of 4 is 2. And this goes on and on and on. What would be the next easiest number to take a square root of? 9, right? So the square root of 9 is 3. This table was also a little bit different, if you notice. Like, we've been going from negative 2 to 2. I didn't put a 2 here because the square root of 2 is not like a nice, pretty number. So let's graph this and see what the basic shape of this function is. We're at 0, 0, 1, 1, 4, 2. If you notice, it kind of just looks like a sideways parabola, but only half of it. Okay? Because if we were to graph both sides, this wouldn't be a function because it wouldn't pass the vertical line test. So, connect these dots. And this is the basic shape. This does not have a domain of all real numbers. The domain starts here at 0. So we have a domain of all of the x's greater than or equal to 0. So from 0 to infinity. And the range starts here at 0 and goes up. So the range is all the y's greater than or equal to 0. So 0 to infinity. Now, whenever I said that it kind of looks like a sideways parabola, it actually is indeed just the quadratic function turned on its side. Because these are inverses of each other, but we'll talk a lot about that later. All right, 2 more. F of x equals x cubed. This is a cubic function. Okay? And all we have to do to fill out our table is just cube these numbers. Now remember that a negative number cubed will stay negative. And this is why. Let's just think about negative 2 cubed. That'd be negative 2 times negative 2, which is positive 4, times negative 2 is negative 8. Right? So negative 1 times negative 1 times negative 1 is negative 1. And then 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So these things grow really fast. Like if this was a 3 here, 3 cubed is all the way up to 27. So yeah, these functions grow really fast, and we don't really have enough room to plot 327. So I've changed the graph a little bit to accommodate us with going all the way up to 8. So at negative 2, we're at negative 8. Negative 1, 0, 0, 1, 1, 2, 8. So these functions make this curve like this. All right, so let's look at the domain and range of these. It doesn't matter how far I go to the left or right, I can always cube these numbers. So the domain is going to be all real numbers from negative infinity to infinity. And it's always going to go all the way up and all the way down. So the range is also all real numbers from negative infinity to infinity. All right, the last parent function that we're going to look at is the cube root function. So just like a square root is the opposite of x squared. A cube root is the opposite of x cubed. You're working backwards. So whenever we fill out the table, we're taking the cube root. So we're trying to figure out what number was cubed to give us negative 8. Right? Well, in the table before, we saw negative 2 cubed is negative 8. So the cube root of negative 8 is negative 2. Right? The cube root of negative 1 is negative 1. So you might notice that these tables are just swapped. The x and y's are just swapped between an x cubed and a cube root. And that's also because these are inverses of each other. So let's look at a graph of these. So now we have negative 8, negative 2, negative 1, 0, 0, 1, 1, and 8, 2. So it looks a lot like the cubic function, only now it's turned on its side. So let's fill out the domain and range. Will the domain ever stop going left or right? No. So the domain is all real numbers from negative infinity to infinity, and the range is also all real numbers from negative infinity to infinity. And these are all the basic parent functions. Goodbye.